Hi everyone, I'm Sang Kim. In the previous video, I showed you how to do single factor experiments in a randomized block design. According to analysis output, we have got significant treatments named as CAR, but the block effect is there is no block effect considering 5% significance level. So this is what we have expected. In this video, I want to show you how to do multiple mean comparisons and Fisher's LSD, which is least significant difference. In our program, if we run EM means function, you can get this output. Let's get this output manually here. So let's see how many replications for each treatment. So we can use count if function and range from column B, press F4 and comma and criteria from H2. Right. For standard error, we can use square roots of MSE over number of replications here. We need to fix the cell. For lower confidence limit and upper confidence limit, we can use this formula mean minus standard error multiplied by t.inv. We consider 5% significance level, so the probability is 0.975. And degrees of freedom is 16 because when we calculated MSE, the degrees of freedom was 16, right? Yeah. So degrees of freedom here. Right. Then we can apply this formula for other cells. And to get upper confidence limits, just we need to change the formula from lower confidence limit minus to plus. Right. Okay, which is same as our output. Right. And let's calculate. Let's get multiple comparisons based on t. For A and B, we can get t statistic for numerator parts is mean of A minus mean of B, and over square root of standard error squared plus standard error of B and squared. Right. So we can get this t statistic for A and B, A and C, and A and D, A and E. So rather than calculate t statistic manually, I want to show you how to use VLOOKUP. Yeah. Then we can apply this formula for other cells. Okay. So VLOOKUP. A. We need to fix only column because we want to apply this formula for other columns, right? And comma and table array, press F4 and comma, yeah, and 2 first and minus VLOOKUP. Select B. In this case, we need to fix row, right? Because we want to apply this formula for other rows. And comma and table array again. Press F4, comma 2 and first. And for denominator parts, we actually have same standard error and same number of counts, so we can use square roots of standard error square root plus let's fix this one. Yep. And again this one, press F4. Right, then we can apply this formula for other cells, for other comparison, I mean. Right, let's calculate p-value. So we need to use t, t function. So the p-value can be calculated by there is minus t statistic also. So 1 minus t dot as of statistic, and degrees of freedom should be 16, comma, and true. Right. In this case, we need to use 2t. Because we consider two-side test, right? Sorry. Right. Then we can see there's some comparisons which has lower than 5% significance level, right? So in multiple T comparisons, only A and B and A and D and A and E comparison shows significant difference considering 5% significance level, right? Let's calculate Fisher's LSD. So this is again in the previous video when I explained about single factor experiments in a completely randomized design. Fisher's LSD is to find out critical value and the significant difference value. Then if there's any comparison which has larger than this LSD, is a significant difference. So this is the formula. So in order to get critical value, we can use this one. Yeah. So t dot imb alpha over 2. So alpha is 5%. So we can use 0.975, comma, and n minus t minus b plus 1. So there's 25 observations, 5 treatments, yeah, A, B, C, D, E, and 5 blocks. So 25 minus 5 minus 5 plus 1. Right, this is critical value. Then if we multiply by this one, we can get LSD. So critical value multiplied by square roots of 2 times MSE and over number of blocks, which is 5. Okay, this is critical, LSD. So again, let's sort out mean from largest to smallest. So we can use sorts function in Excel. So if you click data tab, you can see sorts function, right? So we want to sort data by mean from largest to smallest. Click OK. Right. Then the order is A, C, D, B, and E, right? The difference between A and C, this one, and the difference between C and D is 1.6. and 0.4 and 0.4. So again, A and C, the difference is 2.6. So we cannot say that there is significant difference between A and C, right? So let's give alphabet here. Then again, C and D also there's no significant difference. However, if you consider the difference between A and D, right? So the difference is 4.2. So there's significant difference, right? So we can do we can give an alphabet like this, and we can put alphabet here because when we have alphabet in the same row, it means that there's no significant difference. So again, in this expression, we can say that A and C, there's no difference. Between C and D, there's no difference. However, there is a significant difference between A and D and A and B and A and E, right? In our program, we can get Fisher's LSD result by using LSD.test function. So once you activate agricole library, and then if you use LSD.test with ANOVA output and define treatment here, right? Then we can see this result. So this is LS means and standard deviation and number of replications and lower confidence limits and upper limits, yeah, confidence limits, which is same as this one. And it says that critical value of t is 2.11, yeah, which I showed you how to calculate it. And LSD is 3.118, so here 3.118. And the R expresses the difference like this way. Again, same expression. So if you see same alphabet for here, there's no significant difference between A and C, right? Or C and D. But from A and D perspective, there's no same alphabet. So it means that there is significant difference from Fisher's LSD method. Right, that's it. I hope it was useful for you to understand how to use LSD in single factor experiments in RBD analysis. Please click like and subscribe if it was useful for you to clearly understand it. Thank you.